Now for the design of the experiment. For the data, we used the Yu-Gi-Oh API to request cards in a JSON-like format, and these cards, the cards returned can be uh, uh, based on the delimiters used in the request. So in my case, I just wanted cards from 2011 all the way to 2023. So after obtaining the raw dataset, we remove unnecessary attributes such as ban TCG or card image URL, which is just garbled text. Ban TCG just means that a card is banned. And if a card gets banned, its price tanks, so we can't really predict on it. Named entity removal. So in this stage, in Yu-Gi-Oh card text, all in the card description particularly, cards from different archetypes or of different names are mentioned in the card in quotation marks. By exploiting this kind of pattern, we can quickly and easily remove these named instances and replace them for proxies of equivalent or similar meaning. After this removal, we concatenate all the obtained attributes of the card into a single column, and that will be the target that the text that the machine will analyze, and the target will be the card price. For later testing, because not all cards are going to be equally distributed, some dataset rebalancing will be done so that there's an equal amount of um, data in each price bracket per se. So for the generic model architecture, we use a lot of regularization just to prevent overfitting, like hidden dropout, weight decay, and learning rate. Uh, this is so that the model just doesn't hard learn some of the features of very high priced cards and try to estimate on that. For the max length, BERT has a fixed number of positional embeddings, and at max they're 512. That's why we put that as the max length. From past experiments, the model's BERT model, the base BERT model, generalizes at the 10th epoch anyway, and just for reassurance, I set the epochs to 15. Swish activation just prevents dead neurons and allows for some negative inputs to activate. It I just thought it would be very interesting to see what sort of behavior it would exhibit. um, for the regression setup, we used two datasets initially. So one dataset uses the replaces the named entities, and the second dataset does not replace the named entities. However, SEP tokens are still being used in between each of the concatenated attributes. Um, Both BERT models use the same parameters. So, and as the loss metric, we'll be using SMAPE as its for pure regression. Uh, the ranges that these models will be predicting are anywhere from 0 to 100. So we didn't want any of the outliers affecting the results. Depending on which model performed the best, the dataset that that model trained on will be used for the ensembles. Now, for the ensembles, there will be two classifiers. First, I'll outline the binary classifier. For the binary classifier, we used cards. We relabeled the cards into low and high, so less than $1 or higher than $1, with binary cross entropy being used as the typical loss metric for any binary classifier. Now, for each class that a classifier has, an additional regressor will be trained. So the low dataset will be used to train the low regressor, high dataset, high regressor. For the low regressor, we're using MSE since its prediction range is between 0 and 1, and there shouldn't be too much. It should be rather stable at that range. The higher regressor uses RMSLE. So since it's sorting cards in this higher price range, we still didn't want it to over predict. So it keeps it more stable while allowing for some overshooting. Uh, for the next one, the three target, so in addition to low high, we have the class called medium, which predicts cards between $1 and $7.50. So because we're taking some cards from the high regressor, we train a new high regressor on cards that are not that aren't shared between this and the medium dataset. So, and since the low dataset doesn't change, the regressor can still be used for this multi-target classifier. So RMSE will be used as the loss metric for the, I think it's the medium regressor, just because it's also pretty effective at that range. And even though it's a range with considerably less variance than the high data set, it's still got a few outliers, especially in the $7.50 range, and there's still a very large cluster of cards in that $1 range in the medium data set. Um, yeah, and the high regressor still use the same loss metrics as the one used in the binary classifier.